because the cartilages are shaped like the letter C and they're facing this way. Now, the reason that they're looking like the C, but then all of the material in between each cartilage, we need to make sure that towards the posterior side that there's the ability for that muscular esophagus to have room. So these C-shaped cartilages, okay, their goal is, of course, holding this trachea, this tube, open, and to the posterior side, having that flexibility for the esophagus. Because when we eat, the food that we chew becomes what they call a bolus, a little bowl of food, and it has to move down the esophagus by peristalsis, waves. So that esophagus tube, as we swallow, it has to have the ability to expand, push, recoil. Expand, push, recoil. And the structure of the trachea allows for that. And Brian, when they trach somebody, which one do they cut between? I can't remember.
I know you go inferior to the thyroid cartilage.
Okay. So they're working down this region. Okay. So this would be the point that people would get trached. They would come in and cut the material between those two cartilage. So that becomes, of course, an opening to the exterior environment that they have to be very careful about. Cleaning of the trach tube and the mouth and all that sort of stuff becomes very important. When we begin to look at the structure of this trachea, now, like it is a tube. This is my C cartilage. This is the area allowing for that esophagus. And note my structure as I move down the trachea before it's going to branch. Okay? As I move down, it is still lined with cilia. Now, we're going to find that materials can try to invade all the way down to a point where they call the carina. Okay? At this point, it becomes very painful when the body tries to push that back out. Now, the cilia that's present, one of the cool things about it, because we get mucus production and so forth, it helps to trap little particles. And as the cilia move, it helps to move those particles out, which we try to cough back up and so forth. Now, smokers. This is have you ever known somebody who was a heavy smoker? Okay, and a lot of times when they get up in the morning, sounds like they're coughing up a lung. All right, or you may actually, depending on how heavily they smoke, okay, when they begin to get to coughing, sounds like they're trying to cough up a lung, okay? Because, why? What has happened for that to occur?
Well, they kill all the cilia and all the tissues and everything in there. So, yeah.
Now, this cilia, now remember, this was pseudo-stratified columnar. So it looks like it was column cells with the cilia. Smoking, and smoking anything, ding, 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 okay, all right, y'all hear me on that? Yes, Mama? Anything, okay? it turns these cells into stratified squamous. One layer of the fried eggs. That is not what should be present. What should be present is my columns with the cilia and my goblet cells to make mucus. But because smoking, okay, I'll just say that because that covers all of it. That is where those cells can no longer move any of the particles that try to enter. Mucus is, the secretions, okay? And they, at night, because when you're lying down and you're breathing, that brings in a lot of particles. So get up in the mornings, all of that is within this area, and because they don't, the cells are no longer proper, getting that movement out becomes very difficult.
Just to clarify, the cricothyroidectomy, thyroidotomy, it's actually, so it's inferior to the thyroid cartilage, but superior to the cricoid cartilage, so it's the cricoid.
So they go like through there?
Thyroid membrane right there, it's in the soft spot. And yeah, so you find the thyroid, and then find where the cricoid cartilage begins, and then your incision right in between there.
In between there. Wow. Did everybody get that?
Not a lot of room for error.
Huh?
Not a lot of room for error.
Well, that's because something was going wrong. They've got to help supply the air. That's nice to know because that's something I've just never thought about before. Seen it done, but just never paid attention to the actual feel for what they're feeling for. Yeah. So this structure of these cells is important for moving materials out. This pseudostratified columnar, this cilia that's present is extremely important for getting any type of those materials out. Now, as we look at that structure, one of the things that has become very popular this day and time is the vaping, which actually has worse chemicals in it than the cigarettes themselves.
It's not regulated by the FDA.
There is no regulation there, which means they do not have to be truthful. Well, that's not the right term because that's pretty much the case for everything. But they do not have to put forth the correct amounts of anything that they may list as ingredients.
And now all the fruit stuff is going to be gone. They've just banned all that. So now it's just,
Really?
yeah.
And I don't know if you guys have kept up with it, but it's creating something called popcorn lung. I don't know if you guys have been keeping up with that. This is going to be, right now, at this point in time, they have no cure for it. They actually are not even sure what it is yet. So you guys are going to be facing a whole new issue with lung disorders as y'all move into your fields. I'm just keeping up with it, I just kind of read the articles and everything. I just know that at this point in time, they're not sure what it is or how to cure it.
So they don't know even. I think they call it popcorn lung, they don't know what it is.
The reason they're calling it popcorn is because of the way it's showing up on images, and it actually looks like a spot of popcorn.
It's like your bronchioles,
Like poofed out.
They've popped out from inflammation, and it blocks their ability to do that cellular respiration.
So at least they went from a brick to a popcorn.
I think so. I mean, at this point, yeah. But now, see, the reason for that, when that alveolus is nice and round, like it's supposed to be. Small, okay, because you got 300 million of them, okay, between the two lungs, all right, and therefore small in nature, close to the capillaries. You do anything to change that structure, you have now changed the surface area, which is what happens in diseases such as emphysema. Basically, that alveolus that was nice and small had little surface area, therefore high rates of exchange. They actually, where I got one, because I got 300 million, like two that are beside each other, kind of fuse and open up. They make a huge alveolus, which is now huge surface area, which means exchange is not great. So we end up affecting the actual structure of that alveolus. And that leads to stuff such as emphysema. That's one of the things that emphysema does. In the lungs that we have, the trachea branches into the bronchi. The bronchi are going to branch into the lungs lobes. You'll notice that on the left there are two lobes because we have the area that will accommodate the heart. Okay? On the right, there are three lobes. So these bronchi, the trachea, branch into the bronchi. Bronchi begin to branch. By the time you get to an actual alveolus, one of the grapes, there has been 7 generations of branching that took place. So 1, 2, 3, 4, 5, 6, 7. So by the time you get to the area that's going to be leading into one of these alveolus, okay, there are 7 generations of the tubes coming back out. So, in looking at this structure that we have, we are going to say that we have the base of the lungs, we have the apex part that comes to a point. As we look at a side view, they're trying to show that there is a high amount of blood flow. That the blood flow coming in, we have a huge amount of these arteries and veins that are going to come in to do the exchange at the level of an alveolus. Exchange doesn't occur at any point until we get to an alveolus. Okay, is everybody with me on that? So any type of exchange that is going to occur does not happen until I am actually at the point of one of my grapes and all of the capillaries it encounters. Up to that point, no exchange. So as that branching, as we go from upper respiratory to lower respiratory, where we begin to enter these tubes, branching, first branch, first generation, second generation, third, fourth, fifth, sixth, seventh, okay? By the time we get to the point where we have our exchange, where these cells, this tissue, is in um,